Cool. Test. Perfekt. And with that, I think we are live. I wish you all a very nice evening here in Linz to the 32nd Rust Linz Meetup. I'm super happy to say hello here at the Dynatrace headquarter in Linz. Thank you to Dynatrace for hosting us today, and a very nice greeting to all of the people who are watching us live through the stream. My name is Rainer Stropik. I'm one of the co-organizers of the Rust Linz Meetup, and with me, the second organizer is Stefan. He is currently caring for a smooth streaming, and he will join us in a few moments when we have our community news. What will you hear today? We will start the evening as usual with a round of community news. It's a kind of tradition that we tell a little bit about what's going on the one hand side in the IT community here in Linz, and on the other hand side internationally in the Rust world where we are kind of involved in. After this round of community news will take approximately 10 minutes or so, we are going to start with 2 sessions. So let's start with the introduction and the community news. Let me quickly mention that the Rust Meetup is brought to you by the Coding Club Linz. The Coding Club Linz is a community of IT-focused and IT-passionate people. We are running various different meetups, various different groups, and I will tell you a little bit more when we come to our upcoming events. Now, what are today's speakers? Who are today's speakers? We have Matthias and Unknown Trojan. They will be our speakers today. First, you will hear a talk about writing a fast async link checker in Rust. And the second one will be especially interesting for those of you who have a little bit of C and C++ background. We will hear about adventures with diving headfirst into Rustland. We want to say thank you very much for the speakers taking the time, sharing their thoughts with you, preparing the presentations. We are honored that you took the time to come to Linz and speak at our meetup here in Linz. Now, how can you keep in touch? How can we keep in touch? If you want to keep in touch with us, with the speakers, with Stefan and me, you can always use our Discord server. Here you see the Discord link, and I don't know if Stefan has a possibility to quickly send the link through the chat. Otherwise, I will do that later on. So for those of you who watch via the stream, you will get the Discord invite link in a second. If you are here, just take out your phone, type it in, or take a quick picture. That should be fine. Now, community news. Now, a personal note at the beginning of the community news. One of our largest events for kids is currently taking place. So currently I am on vacation, but I spend my mornings with, let me show you, 50 kids in the age of 8 to 15. They are guests here. We organized the DME camp, the Digital Mile Coding Camp, with more than 50 kids. We were at the HTL Leondig, which is a technical school here near Linz, in the last few days. And now we switched to the Digital Mile, to the Tabakfabrik, which is just around the corner. And there we do a coding camp for kids. And here you see a bunch of impressions so that you see what's currently going on. So this is our summer camp for the kids. Now, the next one is the programming club with the workshops. Our next workshop meetings for kids who would like to learn how to code will be on the 1st of September. So if you have kids or nieces, nephews, whoever, who are between 8 and 18 years old and they would like to learn how to code, they are very much invited to our programming club next meetings, as I said, on the 1st of September. Our friends are at Female Coders. They also run study groups. Female Coders is a local community of girls and women who are in IT or would like to start in IT. They meet together, they learn together, they make meetups together, and I highly recommend taking a look at their website, Female Coders AT. Their next study groups will be on the 6th of September. If you're interested, you can find the details on their website. The next big event will happen in September. So if you ever thought about visiting Linz and you never had a real reason why you should come to Linz, I can give you a reason why you should come to Linz, and that is, besides the Rust Linz Meetup, obviously, that's the Ars Electronica Festival. The Ars Electronica Festival is one of the most prestigious and oldest festivals in the area of digital art. It's worldwide known. People from all over the world travel to Linz to visit the Ars Electronica. More than 100,000 visitors come to Linz and visit various events spread all across the city. And we, as the Coding Club, will also be present. We will take part in the event Create Your World U19 under 19. So again, this will be an event especially for students, for young people who would like to try something. And our main part at the Ars Electronica Festival this year will be an artificial intelligence installation where kids can try to be creative together with artificial intelligence. And we are very much looking forward to it. So that is the Ars Electronica Festival. Our friends at the Cloud Native Community Meetup, they also plan a meetup in the upcoming months. To be more specific, on the 19th of September, they have their next meetup, and I copied this image from their website. It will be at 5:30 Central European Summertime. It will be at etc. And you can find all the details about the content here on the website mentioned on this slide. Then we have Eurorust. Of course, you all know about Eurorust, and we particularly included Eurorust because of Stefan. And I think Stefan can tell you a little bit more about it.
Yeah, so hi everybody. Yeah, I can tell you a little bit about Eurorust. It is the annual Rust conference in Europe right now, so I guess there aren't that many others, but it's meant to be the central European conference for Rust. This time it's in Brussels, so it's supposed to move each year to a different city, to a different location. It's 2 days. There's tickets for individuals and for people who come with the company or where the company pays, and the individual ticket is obviously much cheaper. It's 2 days, but there's also an added extra workshop day on the day before, where I'm doing a workshop about refactoring Rust, and Luca Palmieri from Zero to Production Rust is doing a workshop on telemetry for Rust web applications. So if I wouldn't do a workshop at the same time, I would go to this one because this is actually quite interesting. Tickets are still available, but they are really going fast. So we know that the people are very interested in this conference, which is nice. And if you want to join us, please join. I think Ivan is coming as well. Yeah, and Matthias is also coming. Yeah. Okay, but we see each other. That's a perfect segue. Matthias is not coming, but Matthias will be coming to segue. Not to the Technologieplauschel, to Rust Lab. All right. Sorry, I totally mixed up the slides. Matthias will come to Rust Lab. It's also a Rust conference, also in Europe. It's in the beautiful city of Florence, and I haven't been in Florence for 10 years, so I'm really looking forward to go there back again. I will be there. I'm doing a workshop about refactoring Rust again. Matthias will be there. He will talk about lychee, I guess. Yeah. Ivan, are you coming as well? Ivan will come as well, and many other people. So if you want to join us, feel free to join us. Also for the people in the stream. So if you want to hang out with Rust folks, that's a very good opportunity. And then we have the other one.
Exactly.
The one in the middle, yeah.
Technologieplauschel, a very famous meetup here in Linz.
Exactly. Right between the two major Rust events in autumn will be the major Linz event, which is the next edition of the Technologieplauschel. You know, the oldest meetup in Linz, tech meetup in Linz. We are now doing, I don't know, 5 or 6 editions a year. And the next time we will be at Keba over in Urfa. And we already have talks, and Keba has also a beautiful canteen where we can hang out. So I'm really looking forward to that as well.
Exactly. Perfect. Thank you very much. And I think with that, we are pretty much through.
Okay.
So
can I do a couple of housekeeping rules for the folks
absolutely,
here in the audience?
You right. should.
A couple of housekeeping rules for here folks in the audience. So we have food. It's back there. It's Schnitzelsemmel. It's vegetarian options. It's there's lots of food. So if you are hungry, please don't hesitate to grab something. If you are thirsty, you know, it's hot outside. Stay hydrated. Back in the back side of the room outside. There's beer on tap, there's sparkling water on tap, there's juices. Feel free to take whatever you need, whatever you like. There's also coffee available if you still like that. Restrooms are also in the back of the room to the right. Please, if you're not working at Dynatrace, please stay on the ground floor. If you work at Dynatrace, please also stay on the ground floor. It's after hours. Why would you go up? So, and other than that, yeah, if you have any questions, so just come to me or to somebody with a Dynatrace badge. Around the neck or at the hip, and they will gladly help you. The door will be closed, so if you go outside and grab some fresh air and want to go back again, just wave. I will be outside then, and I will let you in again, or take somebody with a Dynatrace card because they can go in as well. And I guess that's about it. So yeah.
Very good. I think that was it. Today we had a lot of community news. Last time it was summer break. We didn't have much to tell, but today we had quite a few announcements. So it took me a quarter of an hour, 14 minutes, not just 10 minutes, but now we are diving head in the first session. And I would like to invite Matthias here to me on stage because he will do the first talk. And I will hand over the microphone immediately, but I would like to ask my traditional question. Normally I ask, where do you broadcast from? I can ask you, where did you travel from here to the Rust Linz Meetup?
It's been a long journey. Started in Düsseldorf, Nürnberg, and I'm finally here. Thanks, Deutsche Bahn.
Very nice. Very nice. Thank you very much. We really appreciate that you took the time. And now the stage is yours. We are looking forward to your talk.
Just a second for tethering. Looks good on my side. That's a good point. Hold on. It's a magic trick to do. This way. Actually, it's the wrong way. I messed up. My cursor is gone. For everyone watching this on the stream, it's tough. Nah, it's fine, I guess. Just have to work with the delay right now. Made the wrong click. I think I really managed to break it. Okay. Help. Send help. I think I need to disconnect my cable. Thank you. Yeah, I wish it was written in Rust. It never happened.
Need the cable at all, by the way.
I don't need the cable at all?
Need the cable. Yeah, you're just streaming in. That's totally fine. Yeah.
Amazing.
You're here already.
Amazing. But do you think it will work?
There you go.
Not really. So, now that we got this part covered, that's the lychee logo. The slides are pink, but you'll be in for 30 minutes of mystery because it's actually a very, very tedious, very terrible topic. We talk about the web. Actually, we talk about the brokenness of the web. The talk is actually called "So You Can Write a Link Checker in a Weekend." And I'm Matthias. I'm a Rust consultant from Düsseldorf. And I have a list of static analysis tools. It's a long, long list. There's a lot of tools. I started with that list a couple years ago. And as you can guess, a lot of these links keep breaking. So I decided to do something about it. And I wrote a link checker. I tried to do it in a weekend. What I had in mind was, hey, let's live code it. I had a YouTube channel called Hello Rust for a while, and this is part of it. At the end of the week, I had something workable, and it checked my links. But of course, I was not done. I was kind of happy with the results. So here you can see how this thing works. It supports various formats. You can tell it to dump links, all the links from a website. You can tell it to check all the links from README. You can store the output as JSON and lots of other things. It's a link checker. Very exciting. Now, of course, if you ever wrote a project, you know that there's more work to be done than people expect. This is a website from Daniel Stenberg. He is the author of curl. Probably everyone knows curl. Raise your hand if you know curl. Nice. This guy also had the task of building something that everyone would use, and then everyone would tell him, yeah, you can do it in a weekend. So he has an entire blog post about people that tell him all the time that it's such an easy thing to do. So I can do it in less than 100 lines. I can do it in a 3-day weekend. But what they forget is most languages use curl underneath. For example, if you use PHP, chances are you use curl, libcurl to be exact. I can build this in a weekend is what every developer says that has never built anything in a weekend. I really like that. Now, you might be thinking, why use Rust? Well, it turns out Rust is an amazing language for writing a link checker. It has native performance. It has fearless concurrency. So you can play around with various things running concurrently at the same time. It has zero cost abstractions. So if you do it right, you don't pay for parsing. It's all in memory. You don't allocate. You have a minimal runtime. That means you can deploy it everywhere. Again, cross-platform. And it's a self-contained binary. You put it somewhere and it just runs. But this is true for literally every single Rust project, I guess. I mean, for this specifically, we look for a very robust networking ecosystem. It should never fail. And also these things. We have a Tokyo runtime. Everyone knows what Tokyo is? Yeah, it's an asynchronous runtime for Rust. We have a production-grade browser engine called Servo from Mozilla, which we use. And we also have a production-grade, quote-unquote, Markdown parser from Google. And all of this is used by lychee, which is written in Rust. Now, I guess the task is pretty simple. We want to find broken links. Now, first, I guess, we need to define what a link is. But it's super simple. If I tell you to envision a link, then probably everyone has something like this in mind. You're like, yeah, this is what a link looks like. And that's because we're human. We're really bad at parsing stuff, or we assume that it's pretty easy for machines. That's why I want to do a game with you. I will show you something, and then you will tell me if it's a link or not. So if you think that this is a link, raise your hand. Is this a valid link? Yes, it is. How about this one? Show hands. Yes, it still is. Or at least it depends. So it doesn't have a scheme. And if you type it into a browser, it will work because your browser, which is Firefox, of course, will know that you want to maybe check https example.com. www, by the way, is just a subdomain. It's a convention. How about this? Is that a valid link? Raise hands if you think this is a valid link. We have a very bold one down there, but it's not actually, because the scheme is missing. What about this one? Yes, this is a valid link because obviously it's a protocol relative link. That means if you are on a website and you open the website with https example.com and you have / example.com, then it will use HTTPS as well. And if you open the website with HTTP, it will use HTTP. And this is nice if your website supports both. Then you can just say, use whatever protocol you used to connect with me. Is this a valid link? Yes, it is. How about this one? Okay, okay. Do you always lift your hand, or is it just, do you really believe this is a link? Awesome. Yeah, localhost is a valid example for this. What is localhost? Localhost is a convention. Where does it come from? From your etc hosts file. So if you put something into your etc hosts that can resolve to example, then this will be valid. Now, of course, that's cheating, because obviously you would have to do that manually. Who does that? But this exists. So if you go to open your browser and you type AI, probably you have to type AI / then it will show a website, because this is a TLD website. Turns out if you buy a domain and then you decide to host something on the root of this TLD, then your browser can resolve it. And I guess no one would have guessed that this is a valid link. Now, I guess what we can establish is a link is everything or nothing, but at least it's always ASCII. Right. Unless you count emojis. Now, it turns out that there are TLDs which support emojis. One of them is WS. Do you know what this resolves to? Where do you go if you open this in your browser? It's a nice marketing website. Take a guess. What could it be? Oktoberfest? Yeah? Love beer? Well, someone at Budweiser was extremely smart to register that domain. I really like that idea. Not that you could ever type it, but I still like it. Now, how does it work? In the background, they use Punycode. They translate it before they resolve the website. So technically, it's not Unicode. Technically, it's not emojis. It's ASCII, but still, there's a way to resolve it. Same with umlaut domains, österreich.at. I don't know if that exists, but it should. What about this one? Yeah, that's Arabic. It says Arabic, I guess. And this is also valid, or at least it used to. Same idea, Punycode. It turns out there was someone that wrote a list of all the TLD with A records. This is what it's officially called. And they just check regularly if there's something resolvable on these TLDs. And Arabic is on the list. That's fun if you want to parse links, because our task is to parse broken links. And in order to find links, we have to know about all of these edge cases. Okay, maybe you think I can still do it in a weekend. But then there's this other thing. This is a valid link. I don't want to go through all of the details here, but it turns out that you can do a lot with URLs. It starts with a scheme, username, and then password and so on. So there's an entire blog post. I linked it below. Check it out. It's a fun read. But it can also be dangerous. Why? Anyone see the broken link? Where is the exploit? Yeah? Basically, yeah, something like that. I wasn't cheating. You can even see it. There's a difference. You have to have very keen eyes, eagle eyes. Where's my man in the back? Guy with the white t-shirt. There we go. No, actually, it's the slash. You see the slash? The slash is different. It's a bit more tilted. First one is the divide sign. The second one is the normal path. Jesus. So if you click on the first one, this will be an exploit. And I mean, we all know that we shouldn't click on links that we don't understand, but I'm pretty sure that I could even trick a couple people from Dynatrace to do that. That's all because Google decided that .zip is a nice domain name. Let's register that. Emails are easier. mail@example.com. Everyone has an email address like that. Right? Emails are easy, right? Right? Well, same problem. This could work if you decide to register an MX record on your TLD, similar to the A record that we saw before. Turns out that the .tt has something like this, so you could have a mail address like example@tt. No one would ever send you emails like this. That would be ridiculous. And the list is long. It's terrible. But, you know, you can add quotes. You can add 123, 123, whatever. IP addresses, everything goes. But one thing is for certain there. There's always the @ We can count on the @ So this is how we can discern between URLs and emails. Unless Medium decides that they want to have that in their path. And then we're royally screwed because, as you know, slashes are fine in email addresses. How do you ever parse that? Okay, this is what we are dealing with. Lots of fun. And we only covered the first part. We only covered the links part. We haven't even talked about brokenness. What is a broken link? So if you try to explain to another engineer, hey, this is how you find a broken link on the web, you have this notion, this idea how a broken link looks like. You think you go to a page and then it doesn't load. But in reality, that's not true, right? You get a 404 maybe, so it does load, provide some content. Maybe the simplest explanation would be, if it's a 404, then it's broken. Hope everyone gets that reference. Easy. If the status code is 404, it's broken. Now, for those of you that have been on this rodeo before, it's not true. There's 404, but there's also 403. There's 4 something something. So you say, nah, in reality, you want to check if a link is not returning a 200. Well, that's also not enough because there's different 200 states as well, which some of them might be okay. You have 203, for example, or 206, which is no content. So you say everything that is not a 2xx status code. Well, that's also not true. What about redirects? That's a 300 status code. Do you handle redirects? Maybe then you say, well, okay, everything that is above 400 then. But that's not true either, because what about 5xx status codes? Okay, 5xx would be client error, server errors, not client errors. Well, then you might say, also not enough, because maybe sometimes you try again and the link starts to work. So you have a temporal component to it. You want to retry a couple times, maybe, unless it's a permanent error. And this is all great until you're at LinkedIn and it's a Monday morning and you decide to screw the world. You're like, come on, what are status codes anyway? So you decide, my status code will be 999. So LinkedIn returns a 999 status code if they don't want you to crawl the page. And I really hate LinkedIn for this. LinkedIn is just weird because a lot of people tell me that LinkedIn links are somehow broken, and I need to tell them actually it's LinkedIn's problem. So there is an exclusion in lychee, which just checks if it's LinkedIn and then just does some special stuff. The web itself is pretty weird. YouTube sends you 200, but then the video is not found. Now, it turns out the way to check YouTube links is to check the thumbnail. Because when the thumbnail is gone, the video is gone. Now, in lychee, there is a check which says, is this a YouTube link? Then check the thumbnail. But don't always check blatantly the YouTube thumbnail, because YouTube has a lot of pages which are not videos, and you want to check them normally because they, for some reason, work. So to verify that, here's a curl request for a YouTube link, and here's a similar curl request for a YouTube link. If you spot the difference, you're pretty good. There's just one character at the end, minor, small q or big Q, and one video does exist and the other does not. But Twitter is like, hold my beer. I can do it even better, because they decided that Twitter will cut off all the tweets from getting read by fetching a URL. You need to be authenticated and you need to have JavaScript. There used to be a workaround, which was to use the Googlebot user agent, because for SEO reasons they allowed it. But also this doesn't work anymore. And then there used to be a different alternative called knitter.net, which allowed you to open links without being logged in, which is nice. We used that for a while, but then it got even worse. It was a bit of a nightmare, to be honest. And eventually they decided to close down and lock down, and now you have to have an account no matter what. And even Knitter is struggling. That means we had to disable Twitter. Yes, it's very sad. These are the problems that you will encounter a lot. Does anyone know what that is? DOI link? Ever heard of a DOI link? Academia. Probably some of you have studied. Maybe you read a paper once and they sometimes have DOI links because the idea is that they should never break. It's like a unique identifier for a research paper. And turns out they break. And someone sent me an email once and said, hey, I like your tool, but those links are broken. Turns out these are DOI links. What can I do about it? And I told him, okay, nothing I can help you with. It seems like they are legitimately broken. And in order to fix it, you would have to find out who maintains the DOI server. So the way DOI works is every university or every library can register to be a server of DOI links, and then they are responsible for their infrastructure. You would have to literally go to every single DOI instance and tell them that their server is broken, which is exactly what he did. So he went and he's still sending emails to people, for example, to wiley.com, who is one of the maintainers of DOI links, and he says, in capital letters, your DOI infrastructure is broken. I really like that guy. He's very persistent. Awesome. We covered brokenness, we covered links. We're done. Unless there are some edge cases. And there are plenty of edge cases. How would you parse inputs? Let's look at this. We all learned how to write HTML in a text editor, I guess. Unless you're as old as me and then probably used something from Microsoft back in the days. But the beauty of the web is that you can start writing text and then see it on the web. And even if you make a mistake, for example, you forget the end angular bracket, it's gonna be fine. Your browser understands it. That's a nice feature. But it's a nightmare to parse. Because our browsers are extremely permissive. They allow you to not only do this, they also allow you to end a tag with a completely different tag. It's still gonna be fine. And that is my arch nemesis, browsing various inputs. This is an example from Markdown. Someone just recently said, this gets detected as a valid link. I hope you all see that it's not, or it shouldn't be. That's a math equation inside Markdown. Well, parsing error. And if you're the maintainer of a link checker, then this is your life. Yeah, this is me at 2 a.m. looking at the issue. Yeah. Another problem that you will hit is too many requests. Turns out lychee gets used a lot. We get to that in a second. And GitHub doesn't like lychee being used so much because turns out if you check a GitHub repository, you have a lot of GitHub links. So we hammer the servers and we run into those too many request issues a lot. What can you do about it? Well, if you want to be a good citizen of the web, it's very easy. There's a standard for that. Every website, every API sends you headers. Those are rate limit headers. That's the IETF proposed standard. Now, what you should do is just parse these headers, wait for the given time, for example, in this case, 600 seconds, and then continue parsing. Easy. You have 100 pages that you can request. You have 50 remaining. And once you're done, you wait for 600 seconds. Easy. Well, unless you read it. And then you say, come on. IETF is not standardized yet. It's a proposal. I will use my own standard. I will use X minus rate limit. Or you are at GitHub and you say, nah, it should be lowercase. And the reset time should actually be a Unix timestamp. And then GitLab says, yes, you were onto something here. I really like this idea. Actually, it should be uppercase, though. Let's add one more observed header. And also, the reset time should be in milliseconds. Or you are at X or Twitter, and then you do everything lowercase again. And you also use the same time format. So then your parsing becomes case sensitive. Well, I wasn't sure about the standard. So I wanted to look it up. There's two more formats. Vimeo decides to use this date format. And Akamai said, I like it, but let's just change the date format again. But if you want to stick to the standard, use the IETF. There's a standard for it. And I implemented the standard. That's the implementation. Turns out I was the first one to even write any library in any language that I found to parse rate limit headers for some reason. I wonder why. Really. But you can parse them. It's not integrated into lychee yet, but I plan to. And if you want to look up the standard, just go to the website. That's the official website. Okay. Well, what do you do if, for some reason, the page does not send you those headers? And it turns out many pages don't. In this case, you can still use something like a small little algorithm for it. It works like this. You have a bucket, and there's X coins in it. In this case, there's 6 coins. And every time you make a request, you take 1 token out. And the bucket gets filled up at a fixed rate. And this is how you do rate limiting. That's the token bucket algorithm. There's a couple alternatives too. And this is pretty simple. But you would have to track every single website. So every single host would have to be tracked like this. Which is really nice. But then where do you start? How many requests do you send with your first batch? 1, 10, 100? Do you ramp up? Do you not ramp up? Depends. Bot detection is another problem. Cloudflare hates crawling. You need website fingerprinting to get around this. Firefox decided to impersonate, actually curl decided to impersonate Firefox and mimic the TLS handshake because this is how bot detection in Cloudflare works. And then even if you cover all of this, you need to handle JavaScript because the majority of the web only works with JavaScript. This is Google without JavaScript. Looks pretty legit. You get search results. Google does a really great job here. Kudos to the guys from Google. Amazing. I like that their websites work without JavaScript. Unless you use Google Maps, of course. Then you need JavaScript because they just keep you for a full. Well, that's much better than what Twitter does or what Bing does. This is all that Bing loads. Ask me anything. You can ask it anything. It's just not going to answer. I mean, every company does it differently. I really like how Facebook handles it, honestly, because they just declare defeat. I think this is the cleanest feed I ever had on Facebook. So maybe that should be my normal way to browse Facebook nowadays without JavaScript. I really like it. It's much better. It loads fast. So JavaScript is a bit of a problem. We went from rendering HTML with JavaScript because HTML was too slow. And then everything is in JS, but it's too slow. So we pre-render HTML. And then we pre-render all HTML. But that becomes too slow. So we render some pages on request, and then suddenly we render HTML on request again. So we went full circle for some reason. Sometimes unnecessary. And definitely a problem for people like me that want to build tools. Recursion. Say you want to check a website, has a million subpages. When do you stop? You can set a threshold, maybe 100 pages down. You have to keep track of that. But there's more. What if the server never responds? When do you give up? What if the response never stops? Do you ever stop? Like it sends you 1 byte per second forever. What if the server sends no Unicode? Can you handle non-Unicode character sets? What if you read a 1 terabyte file? So lychee supports reading websites, but it also supports reading from disk. And there are big files. And if you read a 1 terabyte file or a 1 petabyte file, at some point you run out of RAM. So you cannot parse the entire thing and then load the links from it, because you won't get to that point because you cannot allocate. And even if you can do that, what if you read a 1 terabyte line? You cannot parse it line by line. You have to yield links as you find them. What if you read a 1 terabyte link? Well, that's another problem. And this is the famous iceberg. Try to summarize everything that we talked about and a couple other things. There's a lot of edge cases. A lot of edge cases. I'm almost done. This is the architecture. It's a bit big for a CLI tool. On the top, you have a collector. Collector collects links, and the extractor extracts links. And it can extract links from HTML, from Markdown, and from pure text. And for HTML, we use HTML5 Ever, which is the engine from Servo. And we also use HTML5 Gun, which is a bit more performant and state-based. There's this thing on the right, which is a fragment cache. Just real quick, if you don't know what fragments are, these are fragments. They're the things that are anchors or IDs. We call them fragments. That's the correct term, actually. Those get parsed, and they get stored in a cache. Because if you find them on a different page, you want to make sure that the fragment exists. Same for Markdown. Markdown can have fragments too. And plain text cannot. Now you have a bunch of links, and then you run it through the below pipeline. You create a client. We use request, and we use the GitHub API. We remap, so that means you can do various remapping. For example, you have a production website and you have a stage website or like a localhost website. You can remap from production to localhost, and every link that you find will be remapped automatically. We filter, you can exclude things based on regex and whatever. We apply some quirks, the quirks that you saw for LinkedIn, for YouTube, and so on. And then we run a check. And the check can either access the fragment cache and see if the fragment is there, or use request or Octocrab, which is our GitHub API client. You can set a GitHub token to get way more requests on GitHub. And all of this gets retried a couple times with some logic. I will get to that in a second. Well, I guess we are talking about Rust, so of course we have to cover this part. Is it fast? Is it fast? In comparison to what? I tried to do a benchmark, very scientific. At the bottom, you see I check 1,500 links max, which is nothing. But the reason is not lychee. The reason is other tools. Because you see a couple zeros, this is when the other tools stop. And by stop, I mean I waited for 30 minutes and they just never came back with an answer. There are tools out there which cannot check 50 links. The one that is sort of decent is called lychee. It's written in Go. And lychee is just slightly faster with that many links. Lychee supports files where lychee does not. And it's also better if you have way, way more links. But at the same time, I wanted to make it comparable to the other tools. So it is fast. And why is it fast? Well, because everything is async. I talked to Ivan yesterday, asked him, hey, should I show some Rust? And he was like, yes, you need to show some Rust. And I told him, the Rust code is boring. It's really boring. He said, more Rust. You need to show more Rust. It's a Rust meetup. So I will show you some Rust code, but actually, in reality, it's really boring. This is maybe one of the more exciting parts, and even that is boring. So what do we do here? Magic. We use a stream. Everyone knows what a stream is. Okay. We return an impulse stream. That means we use infiltrate. Infiltrate is a way to statically say at compile time that your return value will be of type stream, where item is result request. And with that, the compiler can optimize that, and we don't pay any runtime overhead, which is great. And we also don't have to tell it the type, fully the type. Because in reality, impulse stream can be very long. If you know about futures, it can be tricky to write it down even. Now, we guarantee it to return a stream of requests. And the way we do it is we parse contents, and then for each content file, we do the thing below. We send it to a worker. There's this thing here, not this, here. That's kind of the magic sauce. Part then unordered. There's a library for that. I actually quite forgot the name by now. Stream, what is it called? Iter stream or something like that. And they have a stream_ext extension trait. And an extension trait is something that you can attach to any type to extend its functionality. It's like a battery pack or a jumper pack for your type. And what it does is it attaches something to our iter method, and then we can run par then unordered on it. The non-parameter is the params for the workers, and we just pass the input through it. And this way, it spawns up a couple workers. By default, it uses 2 times the number of cores on your machine. So more or less the optimal number with hyper-threading. And then it runs the checking in the background on these worker threads. So they never block. That means you can run a lot of links, like 60,000, 70,000, depending on your network connection at once. And you won't see any CPU usage really, because that's the kernel just doing the work. So the lychee process itself will be extremely bored. It's just sending all the requests to the network card, and then it just waits for the results to come in. I guess if there is anything cool about this project, maybe it might be this. Maybe something that you can use for your own projects. I really like that library. Maybe a small joke. I read that yesterday. I really like it. Tokyo, futures, async await, walk into a bar. They pay, they leave, they drink, they order. Thank you. I'm here all day. Ivan said, we need more Rust. We need more Rust. So I said, okay, let's do one more example. That's an extension trait we have ourselves. It's called retry_ext. And it only has a single method, which is nice. I like my traits to be very small. And it only has a should retry method, and it returns a bool. Why do we have that? Because lychee supports many libraries to check links, and they have different ways to handle edge cases. So for example, we support request, we support hyper, we support octo, grep, and whatever. For example, here is the implementation of retry_ext for request response. And what you can do with this trait is you can say, you have a response, and then you can say dot should retry. And you can use it in a condition. You can say if response should retry, and all the logic is hidden behind this extension trait. So use extension traits. I'm a huge fan. For example, we check the status, and if the status is a server error, we retry. And if it's a client error, and it's not a request timeout, or it has too many requests, then don't retry. Else, if it's a success, don't retry, of course. Or finally, if the status is request timeout or request too many requests, that's when you should check for validity. And if this is the case, then retry. Yeah, if you don't get the logic, it's fine. Actually, there's more. This is the, other part for checking the error, not the response from request. There's a couple things that we do here too. Check if we ran into timeout and whatever. Yeah. Lychee is used by a lot of companies. You might not know by the number of stars. It only has 1,000 stars. And Abu gave me the 1,000 star just before this, and I told him that I will mention his name, so thanks, Abu. It is used by Google, AWS, Azure, HashiCorp, CNCF, Honeycomb, OWASP, Supabase, MariaDB. Lots of companies. And it also checks a lot of links. That's actually quite an old number. I haven't checked in a while, but that's my recent estimate from the public repositories. But I know a lot of people that use it in their own private thing. Critical infrastructure. Is lychee critical infrastructure? I don't think so. There's more important problems. But I also want to raise awareness to this problem in open source. A lot of modern digital infrastructure depends on a lot of small developers like me that maintain these little things, and they don't really get any compensation whatsoever. Does anyone still know this page? That dates me. Ivan's nodding. Nice. Like 10 years younger than me, but you still know that. You're a bit of a nerd. So this is the $1 million homepage. Every pixel costs $1. That's 1 million pixels. Pretty smart idea. Was sold out real quick. People paid for these links. How many do you think are still available? I was surprised. There's a website that checked that, did some research on it. Amazing. A lot. The green stuff is still available after so many years. So maybe you don't need a link checker after all. If that's the real problem, like why? Why do this work? But in reality, you know how it goes. These are the valid links. And a human would not think that these are the real pages that were there before. There's like parked domains, weird blocked stuff. Cyber folks, I really would like to know what they did, but yeah, they are dead. That's unfortunate. It turns out that 50% of all cited links in the Supreme Court are invalid by now, and 70% of cited links in academic legal journals. And that's a huge, huge, huge problem, because we lose knowledge. That is critical infrastructure for sure. And even the Wayback Machine is struggling. The Wayback Machine is a page that archives the web. You should donate. They do an amazing thing. They archived 808 billion web pages. And they describe what they do on their page. And there's a link up here. They compare themselves to the Library of Alexandria, which I think is a fair comparison. So I wanted to learn more about that. Clicked on the link. So, yeah, that's life. There's a website called perma.cc. It's sort of a research combination. You can apply there too, similar as for DOI links. They allow you to host stuff there. They kind of, yeah, take snapshots of pages. But even that, broken. That's a GitHub issue from the open source project from Permo. And it says link to library partners on website is dead. Pretty bad. And I guess this is the point. You are an open source developer. Lots of companies use your project. Maybe, if you're lucky, you get a star. But nothing else. I guess, fortunately, there's still academia. A year ago, some team from Switzerland reached out, led by Professor Olaf Zimmermann. They are from Switzerland, and they asked me if I want to participate in a research project. So Benny and Thomas, they did their bachelor's thesis on link checking, and they used Lychee for their comparison, which is really great. Got a lot of nice contributions from them. So big kudos. And if you think that you want to build something valuable from your open source project, I guess then you have to take it into your own hands. The idea that I have right now is to build something called a Lychee server, which you can host yourself, and then you can connect all of your repositories or your websites and then send reports to it, and you get a dashboard of all the broken links. And this way you find out where the most broken links are, and maybe at the end you can also fix them automatically with a pull request. That would be the idea. Yeah, that's all I got. Thank you very much.
Thank you very much for this super interesting and also quite funny talk. I learned a lot. I would never have guessed that building a link checker is such an interesting and challenging problem. And I definitely was wrong with some of the questions that you asked. So let's quickly check our chat here. The chat in YouTube is always a little bit behind, so they see what we talk in approximately 30 seconds, something like this. So we can firstly ask the question to the audience here. Do we have any questions or comments here? Yes, please. I will repeat the question so that people in the stream also hear it. If I understood it correctly, the question was, what do you do if a page displays a captcha before the website in order to detect robots, right?
Tough one. First, you have to ask yourself, why does Cloudflare show a captcha? Because they want to block automated requests. Now, how do they block requests, or how do they even think about automation? I guess fundamentally, if you have an IP address that is not known to be a spammer, you have a high chance that you can go through the bot detection without really getting blocked immediately, even by Cloudflare. If you are in an IP range that happens to be highly frequently used, for example, if you use the lychee GitHub action, then you are on Azure's infrastructure, then this is a much trickier problem to have. There was an experiment to use browser fingerprinting in lychee 2, because turns out there's a patch for request which does that, and it spoofs the SSL signatures and the headers and so on. But it's very tricky to contribute that upstream, because it kind of patches various things in the SSL layer, and so it would always have to be maintained on the side, which is a lot of maintenance overhead. Now, I think what you can also do is, if you want to access a website with credentials on it, you can go through like this. You can set headers, you can use basic auth. Maybe that helps sometimes. You can change the user agent, which also is supported. That helps sometimes. I guess in the future, it would also be nice to have JavaScript support. You can kind of emulate a real browser. There's this idea that you could have a proxy and use a Chrome browser to drive lychee. You would tell it, hey, just give me the content of that page. But from a CLI tool perspective, you don't want to couple too closely with any browser. And another idea that we had was to run a browser in WebAssembly with just the JavaScript and HTML part, like JS DOM, and trying to fetch the content there. But I guess in reality, it's a very, very tough problem. And the door is not closed. The door is still open. Yeah, the door is open.
We have one additional question from the audience. The question is there a blog post that guides through the code if some people would like to know more about the code here?
That's a good idea. I should probably write one. It's very boring. What I try to do is be very extensive about the documentation on docs.rs. And there's, I guess, a check which will not allow you to ship a version of lychee without any docs for the public interface. There's actually lychee lib and lychee bin, just like curl lib and curl bin, which allows you to integrate the library into your project, even across language boundaries. There's an experiment for Python. But yeah, if you want to contribute, probably the best place to start would be the lychee documentation at lychee.cli.rs. I guess I forgot the link. Amazing, but it exists, and you can find it on GitHub too. And then probably from there, you want to read the docs and then read the source code. Unfortunately, there's no blog post for it, but I will put it on the list. That's a nice idea. But in reality, the code is pretty boring. It's just a lot of checks.
Oh, boring code isn't a bad thing, is it? It's a good thing.
Yeah, it's very boring, if you say so.
We have 2 additional questions. You want to get started?
There's an exception for Crates.io. So maybe just to repeat the question.
Yeah, please, go on.
Crates.io also returns broken links if the link is in fact valid. And that is a known issue with Crates.io. And turns out you can set a header to go around that. So when we detect the Crates.io link, we will set the header for you. So that should work with lychee. Shuttle should use it. Shall I repeat the question?
That would be very nice. Thank you.
The question was, if I can summarize, why are so many links from cited papers broken, and does anyone do anything about it? The answer is me. And people like me, people that care about the open web and care about standards, yes. Why is it broken? Because of link rot. Turns out half the links on a page will be broken in 1.5 years, I guess. So that's the usual way things go. And why do links break? Because people migrate pages, they forget to check links when they do a rewrite of their website, and they don't have control over external links that they link to. Link checking is a fundamentally hard problem, so it requires a lot of infrastructure to do right, as we saw. And people, I guess, don't really see it as a problem too much, so they don't spend money on it, and they don't really care. I guess a lot more companies would care if they saw the revenue that they would lose through it, but there's no visibility right now. What you have visibility on is usually things that make money, not things where you lose money. For example, if you have an affiliate link on your travel blog and you don't earn a single cent with it, maybe you don't even see a problem, because maybe no one ever bought something from it, so no one clicked the link. But in reality, it could also mean that the link is broken and they cannot buy. But this problem is way, way harder to detect. And there, as far as I know, is no tool out there to automate link checking in the background, which shows you some sort of dashboard for even a normal website. I think that's something that developers should tackle, and I was really surprised to learn that. Yeah, if you ask me, since this is taxpayers' money, they should make sure to run some checks and maybe invest in that infrastructure. Yeah. That's just me. Maybe you can support me. Contribute some code.
So, do we have any additional questions here in the room? No? I think with that, we are very much through. We want to say thank you again for taking the time. It was a very, very interesting talk. I learned a lot, and I think we can all agree that this was an awesome possibility to learn more about link checking. Everybody in the stream, take out your clapping emojis here in the room. We can also give a big hand of applause and say thank you. Thank you for contributing to the Rust Linz Meetup.
Thank you.
For a quick message to the people in the stream, we will now have a 5 to max 10 minutes technical break. That means that we are going to switch speakers. We will put up the laptop of the next speaker here. For those of you who are here, maybe you can grab something to eat, maybe you can grab something to drink, and we will be right back in max 10 minutes. Maybe we will make it in 5. We will see. Thank you very much. See you in a few minutes.
Oder in die Dynatrace-Webseite gerade prüfen.
Ah, okay, das wäre eine gute Idee.
Das ist ja offen.
You keep your sanity.
Super. Ja, perfekt. Now the microphone should be live. Can you hear me, Stefan? Okay, for those of you who are watching in the stream at home, now it's the time to go back to your, I don't know, couch in the living room and take a seat, grab something to drink, grab something to eat. Our guests here at Dynatrace are already taking a seat already. So I think with that, we can go right into the second talk of the evening. Stefan, are we ready? Can we go? Very good. So thank you very much. We have our second speaker here, Unknown Trojan. I always ask the first question, the same first question to our guests, and that is, where did you come from? You had also quite a long travel to reach us here in Linz, right?
Yeah, I came from Dortmund in Germany. It was a long train ride.
I can imagine that. So today we have two people. Oh yeah, now it's green. Now it should work. So can you repeat your answer again so that our people in the stream will hear it?
I came from Dortmund in Germany.
Dortmund,
It was a long train ride.
So the Deutsche Bahn didn't have problems? A little bit,
I think
okay,
that's impossible.
but not too bad. Very good. So we have two guests from Germany today here. We are very much looking forward to your talk. You called it Diving Headfirst into Rustland, and I read in the abstract that it will be particularly for people like you who come from a little bit of a C++ background and are now exploring the world of Rust. So we are very much looking forward, and thank you again for sharing your thoughts and your experiences. The stage is yours.
Thank you. Okay, welcome and thanks for attending. This talk is called Diving Headfirst into Rustland, and I designed it as a talk to help C++ developers that maybe want to try Rust not get lost while trying to start learning Rust. So about me, I'm currently employed at the Linz GmbH in Bochum. I've been using C++ for a very long time, basically since I can remember. I have a background in reverse engineering and game hacking, so usually low-level stuff. And upon a friend's recommendation, I tried Rust around 2 years ago, and I've been completely loving it. So I'd like to give back with this talk what I would have loved to have watched myself back then. Yeah, that just says that. Okay, we will quickly, but not too in-depth, go over the style of Rust code, expressions, and parts of functional programming. We'll be going over the memory management, the package management, pattern matching, enums, or tagged unions, error handling, composition as the model of OOP, as an alternative to the OOP, for example, in C++. And we'll also take a quick look at generics. First, though, I want to quickly remind everyone that the documentation for Rust is absolutely amazing, and that this is not a replacement for any of these by far. And if you've read docs before and don't like that and haven't read these before, I recommend trying them because they are really, really good. So about Rust style, compared to a lot of other languages, Rust enforces a pretty strict code style guideline, as opposed to other languages where it's more laissez-faire. Everybody can have their own style. So reading Rust code bases almost always feels roughly the same, which is good if you like the style. If you don't, maybe not. Oh. Then expressions. So Rust makes heavy use of expressions. A lot of constructs like blocks, if expressions, and match expressions. Sorry. Okay, I'm just going to read that one. I'm blocking. A lot of constructs that are statements in other languages are expressions in Rust. For example, blocks, if expressions, and match expressions. This means, for example, if you want to quickly compute a value and just place it as an argument somewhere, you don't have to pre-compute it, put it in a variable, and then assign it. You can then pass it. You can just put that block right there and let it evaluate. C often uses, or basically only uses, switch cases for jump tables and having a conditional branch with a huge amount of potential branches. And Rust, with its match expression, allows a much cleaner syntax than what C users might be used to. As I said before, a block of code is also an expression, which surprised me at first. I was under the impression, code is procedural. It's a procedure, not an expression, but it really does make code a lot cleaner and more beautiful if one knows how to use it. Here's an example of a block of code as an expression. Just very useful in general. Then functional programming. So Rust borrows a lot of concepts from languages like OCaml. It makes heavy use of iterators, making it easy and efficient when operating on collections of data. Usually it's functions that call a closure for every element in a collection and do a certain thing, which you might be familiar with from other languages. I'm sure this is not unique to OCaml or Rust. Then the memory management. One of the biggest talking points when I heard about Rust at first was that memory bugs were harder to make, I guess. And at the time I thought, C++, you can make those errors, but just don't make those errors. It's not worth it to have the compiler hold your hand and, like stop you from doing stuff you want to do. But then when I actually did learn Rust, at first it did feel like somebody was holding me back. But after a while, your code just adjusts and you don't feel the borrow checker at all, and your code is safe. So I believe if this is like an argument for you to not try Rust, to reconsider. The Rust compiler enforces memory safety at compile time this way, using a few rules. Every variable has an owner, and that owner has a scope. When the variable goes out of scope, the variable is dropped, and a certain trait allows the variable to clean up after itself if necessary. The default implementation simply moves the value into a scope and then leaves the scope. Variables are also moved by default, and references to a variable can only be given out in line with Rust's borrowing rules. Oops. That is way farther back. As I'm pretty sure a lot of you know, there can be only one mutable reference to a variable at a time, and no immutable references while the mutable reference is active. This prevents data races and use after exactly. And no immutable references while the mutable reference is active. If the variable is not mutably borrowed, it can be immutably borrowed as often as desired, since when nothing's modifying it, you can't have a data race. This is achieved using lifetimes, which I actually like. My friends don't really like lifetimes. Every variable has a lifetime determined at compile time. And for example, a struct can hold a reference to a variable only if the compiler can ensure that the variable will live longer than the struct will. And we skip right over to package management, which I think is one of the nicest things about Rust after years of shoving shared objects around and linking. Just typing in the package name and a version makes it very, very nice to use. It downloads, compiles, and links dependencies automatically. And Rust has a pretty unified package repository called crates.io that everybody can publish packages to and immediately pull down and compile if they want to. Also adding a dependency from a Git repository or a path is very easy. So you can have multiple projects in a Git repository and simply have them as dependencies on each other. It is also consistently used on almost every single Rust project. So you can have a cargo project, and every other project basically that you will ever encounter will also have cargo. A Rust project is called a crate. It can be either a library or a binary crate. They can expose feature flags that the end user can select and basically shape the library's behavior to their requirements. Crates are versioned using Semver, and when adding a crate as a dependency, you specify a constraint to tell cargo which versions are fine to use. It will pull the newest that matches the criteria and then put it in a log file. And unless you manually tell it to update or delete the log file, it will keep using that version since it's valid in your constraint. Now, pattern matching, which I didn't really think was a thing before I even touched Rust. So it's such an amazing concept, honestly. Makes code so much better. It allows you to match patterns on values, for example, matching a literal, an enum variant, a struct variant, more. In C, for example, you would use, did I not say that before? I did. In Rust, the switch syntax is improved upon with a match expression that allows writing more readable code. And it looks something like this, which I think is better than case 0, print line, and then a break. Enums, my favorite topic here. Rust enum variants can not only be numeric, as in some other languages, but contain any arbitrary type the user wants. For example, Rust has two very common enums that are basically used everywhere in Rust code: option T and result T error. Option can be one of two variants, none and some. So there's no need for null sentinels. If a function can conditionally return a value, for example, option is used to let the user easily match on it and decide what to do. Result can be one of two variants as well, OK and This time, though, the OK variant, which would have been equivalent to none before. No, never mind. It does contain a value T, and contains a value E. It is the enum used for error handling, and if a function can fail, it will simply return a result. And this result, T will be the type you want to return, and E the type containing the error information you want to pass. This makes it easy for the users to match on it and maybe panic if the error is severe or ignore it. It's a user's choice, but I think it's a very good solution. This is an example of how option works. You can match on an option and have it, matched. There's also more complex stuff you can put in an enum, which is actually really nice. You can match on the structs, or quote-unquote structs, members as well. Here we come to error handling. Other languages usually use exceptions, and Rust uses result for error handling, where E is an enum or struct containing error information. The end user can match and decide what to do. And there's also crates that try to make this easier, most notably anyhow on this error, which I really like. I would recommend taking a look at them if you are serious about trying Rust. Here's an example code of using result. So we have an error enum. We have a function that may or may not return an error. And at the very bottom, we have a match statement where we call the error propagation function, which, it calls may error. And instead of directly matching on it, it uses this question mark operator. And that question mark operator basically means if it's OK, then we evaluate this expression to the value contained in OK. And if not, we return back the error, which is really nice instead of having to not throw up, but return the results back up. And then there's an example on using unwrap, which is a very quick and hacky way to develop code when you don't really care about the error state. The error state may be not handleable, so unwrap will crash the program if the error variant is matched. Otherwise, it will return OK. So languages like C++ use inheritance. And Rust uses an approach called composition. The main concept in composition in Rust is a trait. A trait is basically a definition of behavior for a certain object, and many types can have many traits associated with them or implemented. if you want to, for example, have dynamic code in, say you want, again, C++, you want an animal, but there may be dogs and cats. Well, maybe you just want an animal that can walk. So you take a box with a dynamic animal trait. This is a fat pointer with vtable information and can be used to, well, dynamically work with objects matching the trait bound. Generics are a way to have functions, structs, and more take any type matching certain bounds. So this is also similar to templates in a way in C++. And code is generated at compile time accordingly, generating multiple versions of the construct for each real type used. So if you, for example, give the example function an unsigned 32-bit integer and a signed one in two different places, this function will exist twice for the different types in the resulting binary. And miscellaneous things that I would have loved to hear about, because I was confused at it at first. As any body of code is an expression, the Taylor expression of the block is what it basically evaluates to. By extension, functions do not need a return statement, but can simply place their return value as a Taylor expression, which is actually really cool and looks good. Then I quickly wanted to touch on debug derives, because I did not know these existed until like a month after I started. And they're just really useful for quickly seeing the workings of your binary without having to attach a debugger. And with that, thank you for attending. And if you have any questions, feel free to ask them.
Thank you very much. Super interesting. And the first question that I have, it comes from myself. I would really love to have the slide deck, because I often get in touch with people who write mainly C++ code. And this is the perfect slide deck that I can show to them. And maybe we can have a discussion about that. You did an, on my opinion, awesome job putting that one together. So my question is, can you share the slides with us?
Yes, I'm planning on publishing the slides on a GitHub repository.
Nice.
As you just check the GitHub link in 5 hours, 6 hours. I'm also planning on linking a few resources that I think are important for new Rust learners. For example, as I linked before, cheats.rs and the docs, and for example, Rust Linz, which I find very nice. Mm-hmm. Yeah, that's the plan so far.
Very good. Thank you very much. Before I go on with additional questions, let's ask the audience. Do we have any questions to Unknown Trojan at the moment? Yeah, question, please.
Can
you repeat the question, please?
He asked, why do all your friends hate the lifetimes? I think because they'd rather just, for example, with strings, they'd rather just clone it and have an own string rather than having lifetime annotations on structs, which can, in my opinion, also get a bit annoying to deal with, but I think they're great and the proper way to do it. They just don't like looking at lifetimes. Like, I've made code and the only problem they've seen with it was, you've used lifetimes?
Yeah.
Thank you.
Yeah, absolutely. I fully agree. I personally think with all the trainings that I did with people who are new to Rust, lifetimes is one of the concepts that is one of the hardest things to understand. It needs quite a bit of understanding of the fundamentals of the programming language to grasp them correctly.
It has a similar reputation like pointers in C++ and any language, but C++, for example.
Yeah, a little bit. And I don't know what about you, but I still, although I've written quite a bit of Rust code, when I can use lifetime elision is still something that I'm not always sure. I would like to follow up with a question. I do a lot of work with students and people who are new in coding and so on. What do you think, besides lifetimes, are the most complicated things to learn? I have heard quite a bit of quite often that Rust is not a perfect first language. Why? What do you think is complicated with Rust?
That's a very good question. I think lifetimes definitely is one of the most complicated ones or hardest to understand. The borrow checking rules are pretty simple, but it may be a bit hard for some people to quite like grasp it, so to speak. I had a problem with that myself. It's yeah, I don't know. I think lifetimes wouldn't be the most complicated, but the thing new Rust users get stuck the most on. And that's a big reason probably why many people, or not so many people, decide to not pursue Rust any further because the borrow checker didn't like them.
Borrow checker is awesome, but many people that I have, students especially, that approached Rust, they often start with a seemingly simple application, meaning implementing a double linked list. And that is simply a hard problem to tackle in Rust with the borrow checker.
Yeah, especially with the knowledge one has at the beginning of using Rust.
Exactly.
You need to use proper concepts.
Exactly. Stefan, do we have any questions from the audience of the stream?
We don't have any questions from the audience. I have a question though. My question would be, now that you've done your fair share of Rust, how do you
I avoid it as much as possible. I mean, the language isn't terrible, but it has a lot of flaws, and I think the language is just a bit old at this point. And you know, Rust is a fresh slate. We've used what we've learned in the past few decades, and I think it's just a great language going forward to learn, because I think a big part of the industry is going to slowly start migrating over to Rust from C++. And in my opinion, the developer experience with Rust is just straight up better than with C++.
That's a perfect opinion for a Rust meetup, I think. Do we have any additional questions? Yes, there is a question.
What could Rust learn from?
That is a very good question.
I will quickly repeat it. What can Rust learn from C++, if anything? And the second was which features are missing from your point of view?
I'd have to think about that. I literally have touched the language once in the past 2 years. I don't think there'd be much I miss. I mean, no, I don't think I can think of anything right now. But thanks for the question.
Actually, I have a follow-up question, if I may.
Absolutely, should.
What would make your company fully commit to Rust, or what hinders them to?
The question was, what's stopping your company from migrating to Rust? The rough statement. We are fully Rust, actually, which is why I really like the company. We use Rust everywhere we can. It's also just really nice to use in microservices as well. I think the web parts for backend and frontend nowadays actually are great for Rust. Like Rust has done a great job with those. Yeah, thanks for the question again.
This is why I really loved your talk so much, because I see the same problem. I think this is the underlying problem of the question that you just asked. I know a lot of companies who still use C and C++ and simply don't take the time to take a look at Rust, seriously taking a look at Rust, and therefore they are missing something, at least to my opinion.
Yeah, definitely.
Very good. So we all agree. Do we have any additional questions? Yeah, please.
What do you think about
Macros.
I couldn't cover that topic, sadly, but macros are absolutely great in Rust. If any in the audience have used macros in C++, it's a completely different beast. There's much more depth to it. And if just declarative macros aren't good enough, you can just literally write a compiler plugin, a procedural macro that will transform the AST of whatever it is attached to in any way you like. And there's been people have made great use of that with Surdy, for example, which is a great library. Yeah, I think macros are really, really great. I sadly just didn't have the time to fully cover them, I kind of had to skip over. But yeah, thanks for the question again.
Any additional questions? So I have a question. You didn't mention unsafe. Did you ever use unsafe in projects? Maybe because you needed to do things on a lower level that cannot be easily expressed in Rust?
Yes, I have. You know, as I've said before, I have a background in reverse engineering and game hacking, which involves a lot of low-level shenanigans. So using unsafe is relatively common in those code bases. However, it is almost exclusively for FFI or interoperation. Most things internally do not use unsafe. In normal Rust code, let's say you're writing anything that doesn't modify a program or something, I would be surprised to see that more than maybe 10% of projects ever need unsafe, because the language is strong enough without unsafe. I mean, unsafe is good to have sometimes. Maybe the proper solution is a bit more complicated or tedious. And if you can trust yourself and not the compiler, use unsafe. I think people scare off some new developers by telling them off to not use unsafe. I think if starting out, okay, it may not be the best approach, but it's better than just making them not want to use Rust because the community is telling them, you're doing this wrong, you should do this instead. Which, I mean, it can be productive, but from what I've seen, it's usually rather hostile. And for the community, that's kind of sad.
Very nice. Thank you very much. Stefan, do we have any remaining questions from the stream? No.
Just even more approvals.
Even more approvals. Very good. Any remaining questions here in the audience? If not, I want to repeat again, thank you very much for taking the time, taking the long journey. We really enjoyed having you here. And we are looking forward to see your material on your GitHub page. Thank you very much.
Yes.
Please stay around, grab something to eat. Maybe we can stand a little bit together, discuss a little bit. And yeah, with that, thank you again. Thank you for visiting us.
I would just like to say again, thanks everybody for attending. This was my first talk ever. So I might have been a bit nervous, but I hope it wasn't too bad. And to literally everybody in the audience, thank you online and here. It's been great.
We are honored. So thank you very much.
You're going to make me clap back.
Very good. So I think, Stefan, with that, we can wrap up, right? Please check meetup.com for Rust Linz. We already announced the date of the September meetup, but unfortunately I don't have it. I don't have it on the top of my mind, but you can look it up online. We are really looking forward to the next meetup. Thank you very much for watching. Thank you very much for visiting. And if you are here in person, stay a little bit. Let's chat a bit. Let's use the bar outside to have a really nice summer evening here in Linz. Thank you very much and enjoy the rest of the evening.